Hello, welcome. Welcome to the last week of Unit 2. Nice. We're almost there. So we got today, we got Thursday, and then Unit 2 is over. Next week, we don't have class, so take a little break. You've earned it if you've made it through. If you still got a little bit of stuff you need to finish up, we will probably have some TAs here next Monday and Thursday. I haven't heard any specifics about that yet, but I'm fairly confident that there will be help available on those days. I'm going to try to chat with Ryan about that here in a few moments, and we'll keep you posted on that. The deadline to get everything completed and submitted for Unit 2 officially is a week from Thursday, so I believe that'll be the 9th of May, if I'm doing the math right in my head, somewhere in there. So again, I know I've been saying this last few classes, but we're starting to run out of time here, so if you are feeling like you're a little behind on Unit 2 stuff, please talk to us. We want to help you. We want to get you finished up and moving on to Unit 3. So let us know what we can do to help you out. Talk to your TAs, talk to me. We're happy to help out however we can to make sure that you've got everything submitted for Unit 2 and are ready to move on to Unit 3. Are there any questions about Unit 2 finishing stuff or Unit 3 stuff that's coming up? Anybody got any questions? Yeah, what's up?
So we just have a chat here. What exactly are we going to be doing with Unit 3? I think before, maybe in the past, there's been like split tracks for it. Are we like just focusing on one thing all together, everybody now, or?
Yeah, as far as I know, we're all doing Java for Unit 3, and it's not my decision. Launch Code makes that decision, and they tell me, but as far as I know, it's Java. That's what they've been telling me so far. Nobody's told me anything different recently, so we're going to be starting in on Java for Unit 3 in 2 weeks. That's the plan. So it's a different language. That's actually, I mean, speaking from past experience, that's actually one of the biggest hurdles of Unit 3 is that it's not Python anymore, which can throw people for a little bit of a loop. But I think that the good news is that a lot of the concepts that we talked about in Unit 1 and Unit 2 are still going to appear in Unit 3. So if you feel like you get the concepts well from Unit 1 and Unit 2, you don't have to necessarily relearn how loops work, for example, or how functions work, for example. They're just going to look a little bit different since we're doing them in a different language. So that's kind of the direction that we're headed in with the Unit 3 stuff. Any other questions about this sort of transition that we're about to be making here in the next couple weeks before we hop into today's stuff? All right, well, kind of like last week, we're still kind of ramping down on materials. Not a ton of new stuff introduced today, but there was a little bit of new stuff introduced. Has to do actually with what we've been working on for the last week or two, which is primarily the user login stuff. And up until this point, it was very easy. If you wanted to go take a look at the database, you'd see the passwords for everybody right there, sitting there in the database, and that's not very good. That's very bad, actually. And so today we're going to fix that problem. The prep work walked you through how to do that, so we're going to talk about that at a conceptual level here for a moment, and then for the studio, you'll actually implement that as part of Flick List. So let's have a chat. What is hashing? If I tell you that I'm doing hashing, what does that mean? What am I actually doing? One-way encryption, yeah, that's a good way of describing it. So that actually is the answer, one of the answers to the next question that you see up here. What are some properties of hash functions? I expect them to be one-directional. What does that mean when you say one-way? Yeah, Alex. Yeah. It's very hard for me to go backwards. If I give you the result of a hash and say, what did I start with? It's very difficult for you to tell me that answer, right? Which makes a lot of sense considering what we're using it for, right? I don't want to be able to easily, reverse the hash and get the original password back out. I want to keep that original piece of information a secret from as many people as I possibly can. So that's one property of a hash function. What are some others? I think there were 4 that were mentioned in the prep work. Yeah, go ahead. Yeah.
Yeah, so in hash function one
Deterministic.
that really means like every time you input it the same,
Mhm.
output it.
Right, so deterministic, yeah, you defined it perfectly. If I give you the same value over and over and over again, I want to get the same value out over and over and over again. The opposite of deterministic is non-deterministic, which actually means that there's some degree of randomness involved, right? Some degree of uncertainty as to what the actual output will be. So we don't want that. That is our enemy with the hashing function. We want to be able to know for certain that I'm going to get the same results if I plug in the same values repeatedly. All right, so what are some other properties? There's still at least a couple more. Unique. So if I'm plugging in values, I want to make sure that they're going to generate unique values as much as possible. It's difficult to avoid collisions entirely, where if I give you two input values, they produce the same output value. That's what we call a collision. It's difficult to avoid those entirely, but we want to try and use hash functions that are going to make the odds of a collision happening be very, 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 very small. What are the practical considerations of a collision? If a hash function has a lot of collisions, what does that mean for us if we use it on our website? Yeah, they can put in a different password than what your password actually is, and it's going to look like it's your password because it has the same hash value as your password does, right? That's a very bad thing. We want to avoid that if at all possible. Any others? There's at least one more I can think of. We want it to be fast. I've got a lot of people using my website, hopefully. I mean, that's the goal anyway. Got a lot of people using it. I don't want to spend all of my time hashing passwords. I need it to be quick. So one thing that I'm not sure was covered super heavily in the prep work is what a hash function actually looks like. I mean, like, what is it actually doing? It's typically a series of arithmetic operations. It's not even necessarily complex arithmetic operations. You can write hash functions using addition, subtraction, multiplication, and division, right, in various ways to create hash functions. The more secure and complicated hash functions do a little bit more than just addition, subtraction, multiplication, and division, but you can still construct some very simple and still useful hash functions using pretty basic arithmetic. I'm taking one value and turning it into another value, and we're using math to perform that operation. So we want it to be fast. We don't want to do anything too terribly complicated. I think that's it, unless anybody can think of one that I'm forgetting that was mentioned in the prep. We covered the big ones anyway. Yeah. So then how do we do this in Python? If I want to start hashing stuff in Python, what are the steps that I need to take to set that up? Do I have to go write my own hash functions? No. Actually, that's a very bad idea. If you want to do it for the sake of learning how hash functions work, I'm all for that. We do that a lot, actually, in some of the classes that I teach on campus. If you want to use it for practical purposes to actually use on your website, no, please don't do that. Don't do that. What should you do instead? Yeah. Yeah, there are some well-known, some well-defined hash functions that already exist, and we're going to use those in our for the purpose of protecting our passwords. That's what we're going to do. We're going to use the already existing, already vetted. So there's lots of security professionals who have already verified, right, that these hash functions are going to be secure under certain conditions, and then the experts have actually implemented the hash function, so I don't have to worry about if I made a mistake in a particular area, right? So I'm not even going to take a risk with it. I'm just going to use some predefined hash functions that I know have been verified correct by the professionals. What are some examples of hash functions that you either saw in the prep work or maybe you've heard about in other areas? think the one used in the prep work was hashlib is where they came from, but the actual hashing function. So hashlib contains a lot of hashing functions, right? There's many to choose from. The one that was used was, yeah, SHA-256, yeah, is the name of the actual hashing function that they use. It's a pretty common one. And so, if you're ever interested in learning more, right, you can easily find information about hashing functions. So we've got this will even show you how it's computed if you're interested in the details, right? This is important to kind of keep up with as well, because actually it is true that over time certain hash functions are cracked, right? They're figured out. People figure out how to break them. So it is important to kind of keep up to date with current trends and make sure that you are evolving your applications to use the most recent and most modern hashing functions when appropriate. But there are others. Anybody know of any others that they've seen or heard of? I'm sorry? MD5 is a very common one as well. Very, very common one. But you can see right here, right? It's been found to suffer from extensive vulnerabilities. So not the best one to use anymore these days. It has other non-security related purposes that it's still very useful for, but if we're considering using it for security related purposes, probably not the best choice. There are lots of others. RSA is another common one that we talk about. Oh, have to be a little more specific, I guess. RSA hashing is another very, very common one. But there are lots. There are lots and lots and lots and lots. And honestly, as a developer, it's probably not necessary for you to understand how each of them actually work, or the internals of all of these different hash functions, although you might find that interesting. I find it interesting to know how they work. But the nice thing about the widely used ones is that it's very publicly available. A good hash function, I should be able to tell you how it works, and you should still not be able to crack it, right? Like, that's the sign of a good hashing function. You know how it works, and you still can't break it. That's a good sign. Cool. Let's see, were there any? Oh yeah, we did have one more topic here. What does it mean to salt a password? Why do we salt a password? What's the problem? Yeah, go ahead. Yeah. Rainbow tables are a problem. So rainbow table actually exploits one of the properties that we talked about. If I plug in the same value, I get the same value back out. So what does that mean? That means if I have a way of computing SHA-256 hashes, I can plug passwords into it and see what the hashes are going to come out as. And then if I see that hash anywhere else, I know what your password was, right? That's probably the quickest and easiest way to reverse the hash. It still could take a long time to find something that you're looking for when you consider all the possible password combinations that exist in the world. But then you have to remember things like, well, people usually use words and phrases in their passwords to make them easier to remember. It's not just a bunch of random stuff, right? Things like birth dates are common, things like that. And then not only that, but we also do something else that's really bad, usually. We reuse the same passwords over and over and over again. So if I find the hash of your password on one website and I figure out what it is, then I can go try it on other places, and that makes it even worse. So just because we're hashing passwords doesn't mean you're safe. In fact, it happens, I feel like, to almost everybody these days when a website they're using gets compromised somehow. It's happened to me multiple times, right? The best thing you can do is not reuse the same passwords over and over and over again. And so one way that websites use to try and protect against the fact that people are going to reuse passwords over and over again is to salt the password. So what does it mean to actually salt the password? Yeah, go ahead. Mm-hmm. Yeah, so when websites salt a password, right? They're adding a randomly generated chunk of stuff to the end of the user's password. What they're basically saying is, I don't actually trust you to choose a very good password, so I'm going to generate a bunch of random stuff that will make your password stronger and add it onto the end of your password. That does complicate the process, though, of logging in a little bit, right? Because now I need to know not just what the password was, but what the random chunk of stuff was as well to make that work, correct? And so it does take a little bit more effort. It does take a little bit more work. In practice, it's not that bad. We just end up storing that salt in the database along with the hash so that we can recreate it when necessary. But the upshot of this is that for every website that I use that's salting passwords, which is hopefully all of them these days, it's a very common practice, I'm going to get a different salt, which means my password technically is different for each and every website, even if I just use 1, 2, 3, 4, 5, 6 for every single website that I log into, right? Still technically looks different. So yeah, the downside of this is that, you know, by storing the salts in the database, if somebody hacks the database, they get the hashes and the salts, and while it's not going to be easy for them to redo that process, you can figure that they can try all the common passwords, tack the salt on the end, and see if they find the matches, right? So it's still possible by having access to the salts as well as the hashes to crack your password. We've just made it more difficult. And that's actually, I mean, a common security concept, right? Is just a matter of how difficult it is. How much effort does somebody have to put in to crack your password? Because after a certain point, it's just not worth it. After a certain point, it's not worth it to crack your password anymore. And you know, there may not be enough resources, you know, available to make it worthwhile either. So we're just trying to make it as hard as possible. At the end of the day, it's an arms race, and the hackers can always find a way, right? If they have unlimited time and unlimited resources, they can hack any password they want. That's a fact. That is just a straight fact. If I have all the time in the world, all the computing power in the world, I can figure out your password. But for a lot of what we do on day-to-day, what are you going to do if you get access to my Facebook password? Make fun of me a little bit? Right? I don't know. Bug my friends? Okay. I don't like them very much anyway. I hope none of them are watching this video. But, you know, after a certain point, it's not worth the effort. Are there any questions? Any questions? I think that's all we had for you today. We don't have a walkthrough today. The studio is much like it was last Thursday, so we're just going to turn you loose and let you start adding the hashing and salting functionality to Flick List. This is actually, I believe, the last modification we're going to make to Flick List. We might make some small modifications on Thursday, but this is the last functional change that we're going to make to Flick List for this particular unit. So now's your chance to fix up any lingering features or bugs that you may have with your implementation. And as usual, we will regroup towards the end of class today and go over the studio. It's also a great time for you to catch up on Unit 2 stuff, right? So if you need help catching up on past assignments, getting help with blogs or build a blog, please let us know so that we can get you what you need to get across the finish line for Unit 2 and into Unit 3. Thanks, everybody.